Okay, guys, we're going to talk about inclined planes today. So please have your chapter 4 guided notes opened up. Be following along where we are talking about inclined planes. Before we get started, though, what's another way to say, or what's another name for inclined planes?
What? Ramp?
It's a ramp, right? Yeah, so an inclined plane, I want you to make this note in your guided notes. An inclined plane is a ramp. They mean the same thing, right?
Yes, sir.
Okay, so like it says here, inclined plane has been used as a machine for centuries. There's a lot in that. It's a machine, so what does that mean? It makes our job easier. What does it make easier for us?
Pulling something upwards.
Is it easier to lift this block straight in the air, this height? Or would it be easier to push it up the ramp?
Push it up the ramp.
Yeah, it's kind of implied that if it's a machine, it makes something easier. It is easier for you to push this thing up the ramp to get it to this height than it would be for you to just directly pick it up and lift it, right? It requires less force to push it up the ramp than it would just to pick this thing up over here to this height. Okay, so it's a machine. People have been using ramps or inclined planes for centuries. Okay, pushing a block up an inclined plane is easier than lifting it. Okay, we can calculate a mechanical advantage, and we will during the lab for this part of the chapter. But anyway, that's an inclined plane, also known as a ramp. It's a simple machine, provides a mechanical advantage. We're going to learn how to solve for all the forces that exist on this block on an inclined plane. Now, what's going to make it complicated is this part right here. What is this? It's an angle, right? This is an inclined plane at some angle. I don't know, this might be 20 degrees. Will that complicate figuring out all the forces? Yeah, a little bit. How come? Nothing's straight anymore. So what are we going to have to use? Trigonometry. Okay, so let's kind of get back into that idea of thinking about trigonometry. What are the trig functions that we talked about? Yeah, sine, cosine, tangent. What's an easy way of remembering all those functions? Yeah, so please write this in your guided notes. SOHCAHTOA. Okay, just to remind you, sine is what? Opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Okay, we're going to see triangles. You're going to have to remember that and how to solve for different sides of the triangle today. Okay, so let's get started here. It says this is all the forces on an object on an inclined plane. You're going to be able to draw all of these forces by the end of this video. Let's just kind of briefly go over it. I think if this is the block right here, the easiest place to start is by drawing the force of gravity. Which way does the vector point for force of gravity? Straight down. Always toward the center of the earth, right? So it always points straight down. So there's a force of gravity. You guys don't have this in your notes, so just look up here for a second. Force of gravity. Now, we talked a lot about the normal force. Okay, I just put it as a capital N. Well, normal force, guys, is a little bit different because now we're on an inclined plane. Normal force always points perpendicular to the surface of the object. So now it's going to be at a little bit of an angle up. Okay? If you're pushing the block up the ramp, force applied is going to go up. And if you're trying to push it up, then friction always opposes motion. So friction is going to point down. But there's a couple more forces that we need to figure out how to know where they're at and to calculate them. One of them is force of gravity in the y direction, and one of them is force of gravity in the x direction. So we know force of gravity goes straight down, but there's a component of gravity called FGY, which is called force of gravity in the y direction because it's more in the y-axis. We're going to have to figure that out. There's also a component of gravity called FGX. It's called force of gravity in the x direction because this one's more horizontal. Here's why we always have to figure them out. FGY, whatever it is going to be equal to the normal force. Is this block moving up and down in this direction? No. So according to Newton's first law, the forces have to be balanced. In order to figure out what normal force is, we need to figure out what force of gravity in the y direction is. Also, if we just put this block on the inclined plane and let go of it, what's going to happen? It's going to slide down. Why? What force is causing it to slide down? Force of gravity. Well, gravity points straight down toward the center of the Earth. How come it's sliding down the ramp? Yeah, there's a component of gravity called FGX, force of gravity in the x direction. Notice that this vector is directly parallel to the ramp. So that's the force of gravity that's pulling it down the ramp. And so we're going to have to solve for it. All right, so drawing this triangle is going to be like one of the main skills that you're going to learn today. And you're going to have to do that. Okay, so let's get started on an example problem. This is in your guided notes. So please write down everything that I write down and we'll talk about how to do this, okay? It says, find and label all of the following forces. So let's just go through them one at a time. Force of gravity, okay, draw it in there. If this is the block, force of gravity always points straight down toward the center of the Earth. Okay, then we're going to label this vector force of gravity, F sub g. Let's find and label FGX and FGY. Well, we know that, I think maybe it's easier if we draw in the normal force first. Normal force comes straight up, perpendicular to the surface of this ramp. So this is normal force. Well, the normal force, if you continue it through on a straight line, if you continue that normal force line, it makes force of gravity in the y direction. And then by connecting the right triangle here, this leg of the triangle is called force of gravity in the x direction. Okay? Now, a couple of things that I like to point out, since we're learning about it. Force of gravity in the y is equal to what? Normal force. Yeah, this block is not moving up and down, so whatever is going in that direction down, it's going to be balanced by the force that's going up. Okay? Force of gravity in the x here is parallel and should be parallel to the round. Okay? So drawing that triangle is the complicated part of inclined planes, but that's how you would do it. Your force of gravity is always going to be the hypotenuse. Okay, one other thing to talk about. If this angle on the inclined plane is 30 degrees, this angle at the top of your triangle is equal to 30 degrees. Okay, so this would be 30. So let's fill that in. 30 degrees. Okay, let's label these other forces. Normal force we did. And then number 5 says, what force would you have to apply to keep the block from sliding down? Okay, let's label the forces that are causing it to slide down. What force is causing this block to slide down? Isn't it the force of gravity in the x direction? Okay, so let's put that in here. Force of gravity in the x direction is causing it to fall down. Okay, now where's our force applied going to go? It's going to go up because we're trying to hold it there, right? So let's label it force applied. Okay. That's our force applied. Now we've got one more force. It's called friction. Friction always does what, guys? Opposes motion. And if you were to just let go of this, which way would it go?
Same way with the force applied.
Yeah, the block wants to go down, right? And so we're trying to hold it so that it doesn't slide down. Which way should we draw in friction? So, but it wants to slide down, so which way does friction go? Friction always opposes motion, so I'm going to put force of friction going up. Does that make sense? Because we're not moving the block up, we're just holding it there so that it doesn't fall down. It's falling down because of force of gravity in the x. It wants to move down, so friction is going to point up in this case. Okay. Now we've labeled all the forces. Now we've just got to put magnitudes to them. The easiest place to start is by finding the force of gravity. Okay? How do we find force of gravity, guys? Well, it's equal to mg. What's the mass of that block? 20 times 9.8 is 196. 196 newtons. Okay. Now, let's solve for the sides of this triangle. Let's solve for force of gravity in the y and force of gravity in the x. Okay, remember our trigonometry. So, toa. Okay. Let's solve for force of gravity in the y first. If this is our angle, this side is right next to it. What do we call that side? That's the adjacent side. And we already have the hypotenuse. So which trig function should we use? Cosine. So let's do that over here. Cosine of 30 degrees is equal to adjacent, which is force of gravity in the y, divided by I don't know what's going on with the board. Divided by the hypotenuse, which is 196. How would I solve for force of gravity in the y, guys?
Cosine of 30 times 196.
Good, yeah, we've got to times both sides by 196. Okay, it cancels out on the right side, and so 196 times cosine of 30 is what, Cole?
169.7.
169.7. Let's round it to the nearest whole number this time. What is that? 170. Okay. So force of gravity in the y is equal to 170. Perfect. Okay, let's label that on our triangle here. This is 170 newtons. Okay. Now, how would we find FGX? It looks like it's directly to the other side. What is that side called? The opposite. And we have hypotenuse, so now we're going to use what trig function? Sine. So we're going to put sine of the angle, which is 30, is equal to opposite, which is FGX, divided by the hypotenuse, which is 196. Okay, again, to get FGX by itself, we need to times both sides by 196. Okay, so 196 times the sine of 30 is equal to 98 newtons. So FGX is equal to 98 newtons. Okay, let's put that in our free body diagram down here. This is 98 newtons. All right. Once you get the triangle all figured out, the rest of the problem really is pretty easy. Okay? FGY tells us what? The normal force. So the normal force in this case is going to be equal to 170. How come? Because the block's not moving in this direction. So whatever's down, the forces down, have to equal the forces up. They're balanced. 170. Okay, do we know the part of gravity that's pulling it down the ramp? That's FGX. So let's label this one 98 newtons. Okay, we don't know force applied, that's what we're trying to solve for, but we really have to solve for force of friction first. You guys remember how to solve for friction? It's equal to what? Mu times normal force. It told us the mu was 0.2, so 0.2 times 170. What does that equal, Cole? What does that equal, Cole? 34. 34 newtons. Okay, so let's put that on our diagram over here, 34 newtons. Okay, 34, that's what that says. And newtons. All right, now, let's go back to what it said. What force would you have to apply to keep the block from sliding down? So you just want to hold it there. If it's not moving, what does that tell us about the forces? That they're balanced, right? So everything down equals 98. So that means everything up has to equal 98. So everything down is 98, and that's got to equal everything up, which we don't know force applied. But there's also another force going up. Friction is 34. How can we solve for force applied? What's 98 minus 34? So force applied is equal to 64 newtons. So just to hold that block there, you're going to have to put 64 newtons of force. You're going to have to apply that much force to keep it. Does that make sense? Okay. So that's a typical inclined plane problem. Let's actually go through and solve some practice problems now. So practice problem number 14. I didn't have the room to put this one on your guided notes, so take a second and draw this. So draw this scenario there for practice problem number 14. And then go through and label all the forces on this block that you can think of. Okay? Label all of them. See if you can get that far on your own. And then once you've got them all labeled, then turn it on. We'll hit play and we'll see if you got them right. Okay, so I hope that you were able to at least draw this much on your free body diagram. So where I always start is force of gravity down. Then if normal force is perpendicular to the surface here, I draw in the normal force. And then just continue that normal force straight down, and that makes your force of gravity in the y. You make your right angle here on this triangle, and FGX, force of gravity in the x direction, is the bottom leg of that triangle. Okay. Also, if your inclined plane is at 27.2, this angle right there is equal to 27.2. Okay. All right. It says find the component of gravity that is parallel to the ramp, so FGX. We want to find this one. Okay. So it looks like we have to find the opposite, and we should be able to figure out what force of gravity is. Let's do that now. Force of gravity is equal to mass times g. So if we do 50.1 times 9.8, it's 490.98. Let's round it to the nearest whole number. What is that? 491. Okay, so 491. Now we can solve for force of gravity in the x. How would we do that? What trig function should we use?
Sine.
Opposite and hypotenuse, that's sine. So sine of 27.2 is equal to the opposite, force of gravity in the x, divided by the hypotenuse, which was 491. Okay. We're going to times both sides by 491. Did you guys get 224?
Yes.
So FGX is equal to 224 newtons. Okay, so I'm going to label that 224 newtons. And this, pulling it down the ramp, will also be 224 newtons. 224 newtons. Okay, let's see what else it asks us to find. Find the component of gravity that is perpendicular to the ramp. So this is the part of gravity that's perpendicular to the ramp, FGY. Okay, now we've got to solve for the side next to it. What do we call that side? The adjacent side. So we're going to use cosine. So cosine of 27.2 is equal to the adjacent side, which is force of gravity in the y, divided by the hypotenuse, 491. Okay. Cancels out over here, so 491 times the cosine of 27.2. 437. Thank you, Cole. That is correct. So force of gravity in the y, 437. Let's label that there. And if FGY is 437, what else does that tell us? Normal force is 437. Again, because of Newton's first law, this block is at rest. It's not moving in this direction, so the forces have to be balanced. Okay, what else is it asking us to solve for here? It says determine the acceleration of the block below if the coefficient of static friction is 0.343. Okay, so mu is equal to 0.343. We want to find the acceleration of the block. Now, which way is friction going to point in this case? Upwards. How come it's up? I agree. It always opposes motion, and if you were just to let this block go, gravity is going to pull it down. And so friction is going to point up. Okay. Can I solve for friction now? Friction is equal to mu times the normal force. Okay, so let's solve for force of friction. If mu is 0.343 and the normal force is 437, it's 150? Okay, so force of friction is equal to 150 newtons. Okay. Now we have everything on that free body diagram that we need. If we wanted to solve for the acceleration of the block, first of all, will it accelerate?
Yes.
How do we know that? Yeah, there's a net force because this one pulling it down, this force pulling it down, FGX, is greater than the force of friction that's opposing it, right? Okay, so how would we find acceleration? Which one of Newton's laws is that? Second law. So force net. Let me see if I can find a spot on the board that works. Force net is equal to MA. How do you find force net, guys? Well, you take everything that's going down, 224, and subtract off everything that's going up, 150. And that's equal to the mass, which was 50.1 times the acceleration. But we don't know it, so I'm going to call it A. Okay, what's 224 minus 150? 74 is equal to 50.1 times A. Divide both sides by 50.1. 1.48 is equal to acceleration. So that, yeah, is 1.48. And what's the units? Meters per second squared. Okay, so pretty cool. We can figure out how fast the block is going to accelerate down the ramp, right? Okay, let's go to practice problem number 15. And this one's asking a little bit different sort of a question. But again, I didn't have room to include this in the guided notes, so please take a second and draw that scenario. And it says, if the acceleration of the block is 5 meters per second squared, what is the coefficient of kinetic friction? So we want that coefficient of kinetic friction. So, this one's going to be a little bit different. Do we know its mass? Yeah. Do we know its acceleration? So can I solve for the net force already? Yeah. I can already solve for that and know it. And so from the net force, you should be able to find enough of the forces to figure out what the coefficient of kinetic friction will be. You guys try it on your own. If you're watching the video, please hit pause. Try it first. See if you can come up with what the coefficient of kinetic friction is on your own. Once you have an answer, hit play and see if you got it right. Okay, guys, let's see if you got this one answered correctly. All right, I always like to start with the easiest force first, which is what, guys?
Gravity.
Force of gravity. So we're going to draw that one straight down. Okay. Normal force goes perpendicular to the surface, and then if you just continue on that track here, we can draw in our triangle. This is force of gravity in the y. This one would be force of gravity in the x. Okay. We know that force of gravity in the y is going to be equal to the normal force, and force of gravity in the x is going to be what's pulling this block down the round. Force of gravity in the x. Okay. All right, let's see if we can solve, at least put a magnitude to those forces first. Force of gravity is equal to mg. So 20 times 9.8 is 196. Okay. If this ramp has an angle of 60 degrees, we know that this angle up here is 60 degrees. So now we can use our trig functions. This one is adjacent, so I'm going to use cosine of 60 is equal to FGY. Okay, so cosine of 60 is equal to force of gravity in the y divided, that's your adjacent divided by hypotenuse, which would be 196. So when you solve it, 196 times by both sides, cancels out over there, times the cosine of 60. Are you guys getting 98? So that is equal to 98 newtons. So let's put that in down here. This is 98 newtons. Okay, now let's solve for this FGX. It's opposite, and I have hypotenuse, so that's going to be sine. Sine of 60 is equal to opposite over hypotenuse. Again, times by 196, both sides. So 196 times the sine of 60. Are you guys getting 170? So this is equal to 170 newtons. Let's label this one 170. Also, we know that force of gravity in the x is 170, right? Up here. What is the normal force going to be? 98 newtons. Okay. So it wants to know the acceleration of the block, or it gave us the acceleration is 5. It wants to know the coefficient of kinetic friction. Which way is friction going to point, guys? If I let go of this block right now, which way is it going to move?
Down.
It's going to move down. So which way is friction going to point? Friction is going to point up. Okay. And friction is equal to mu times the normal force. Okay, did it say anything about an applied force anywhere? It didn't say, right? So we're not going to include an applied force. We're just going to assume it's just moving down the ramp. Okay. If I have acceleration and I know its mass, what can I figure out? Force net. So let's figure that out. Force net is equal to its mass, which was 20, times the acceleration, which was 5. So force net is equal to what, guys? 100 newtons. Okay. And which way is it accelerating? Down. So there's got to be a net force of 100 newtons down. Okay, so how much is friction going to be?
70.
Yeah, friction's got to be 70 newtons. Okay. In order for there to be a net force of 100 newtons down, friction would have to be 70. But that's not what it really wanted. It wanted this coefficient of friction. But now that I know the force of friction 70, I don't know the coefficient of friction. Do I know normal force? Yeah, that's 98. How do I get mu by itself? Yeah, so what we've got here is 70 is equal to mu times 98. So I'd have to divide by 98, both sides. What does mu equal, guys?
0.7.
0.7. So 0, is that right?
Yeah.
0.7. Does mu have units? Nope, it's just 0.7. Okay, so they asked it a little bit different, but as long as we know how to solve for all the forces here, and remember Newton's laws of motion, we can get it. Okay, practice problem number 16. Let me help you get started, then I'll give you some time to figure it out. Again, I didn't have room to draw the scenario, but let's draw it. Okay, it says, what force is necessary to keep a 2.00 times 10 to the third kilogram car moving up a 15-degree incline at a constant velocity? And it gave us the coefficient of friction was 0.2. Okay, so let's draw this ramp, or this inclined plane. What was the degree? 15. Okay, I'm going to draw the car just as a big block here. And it gave us the mass, but it did so in scientific notation. How do we switch that to standard form?
2,000.
Yeah, this 3 tells us we need to move the decimal 3 times to the right, and if you do, that adds another 0. That's 2,000 kgs. So let's put that in the block here, 2,000 kgs. Okay. Mu was 0.2. Another thing that we can get out of this question is it says that it's constant velocity. It wants to keep moving up. So it's going to move up the ramp. This is the applied force, right? So we know there's an applied force. But constant velocity, what does that tell us? Balanced forces.
Yep.
Okay. Good. So I want to give you some time now. You guys take this problem and see if you can solve for force applied. Okay, I want this force applied. Once you're done, then hit play and see if you got it right, but hit pause and tell then. Okay, so let's see if we got this right. It's always easiest, I think, if you just start with force of gravity down. We're going to put all the forces that's acting on this car. So force of gravity, which is equal to mg. Let's just quickly figure out the magnitude of that.
19,600.
Good. 2,000 times 9.8. Good. So 19,600 newtons. Let's round all of these to the nearest whole number so we can get rid of the decimals when we get them. Okay. All right, so now we know that the normal force goes perpendicular to the ramp, and that normal force kind of continues down below it and makes FGY. We make the right angle here, so this is FGY, and this one is FGX. Now, if this inclined plane is 15 degrees, we know that our angle at the top of that triangle is 15 degrees. So now we can use our trigonometry to solve for FGY. That's the adjacent side, and I already have the hypotenuse. So we're going to use cosine of 15 is equal to FGY over the hypotenuse of 19,600. times both sides by 19,600. And so FGY is equal to, what was that called?
18,932.
Is that correct?
Yeah.
Okay.
That's what I got.
Newtons. Perfect. Okay, thank you for that. Let's do, so that's what FGY is equal to. Let's figure out what FGX is. Now FGX is opposite, so we're going to use which trig function? Cosine. No, sine. Yeah, you got me there. All right, so sine of 15 is equal to opposite, which is FGX, all over the hypotenuse, which was 19,600. Okay. Again, we're going to have to times each side by 19,600 to get it off that right side. Okay. And Cole, what did you get FGX equals? 5,073
Yeah.
newtons. Okay. That's what FGX is equal to. Okay, so once you get that triangle done, it's kind of a piece of cake from here on out. So we know that normal force is going perpendicular to the surface of that ramp. What is it equal to?
18,932.
Yeah, 18,932 newtons.
Wow.
Again, because the block is not moving in this direction, we know from Newton's first law that the forces acting on it are balanced in that direction. Okay. What force is pulling this car down that inclined street?
Force of gravity in the X.
Good, the force of gravity in the X. Good. Notice that this force of gravity in the X and the ramp should be parallel. If you continue these lines out, they should be parallel to each other. Since we've already solved for FGX, was 5,073. Might as well label it there. Okay, now the car is moving up the street or up this hill. So which way is friction going to point? It always opposes motion, so we're going to have force of friction going downhill. Can we find force of friction? It's equal to the coefficient of friction times the normal force. Well, it gave us the coefficient of friction was 0.2, and we now know the normal force was 18,932 newtons. Okay. Cole, what did you get when you did that?
3,786.
Okay, 3,786 newtons. So I'm going to label that in the free body diagram as well. 3,786 newtons. Okay. Do I have enough information now to solve for force applied? Yeah. Okay. Again, the key to this problem said that it was the car was moving at constant velocity. Constant velocity, according to Newton's first law, the forces have to be balanced. So everything down, this is everything down the hill, has got to equal everything up. So what does force applied equal? 8,000 what? 859 newtons? Yeah. Yeah, if you take these two numbers right here and add them together, you will get 8,859 newtons, which is what our force applied. So, okay, very good. I've got one more problem for you guys to try. Now, this is kind of a challenge problem. There's a lot involved in this problem. So, let me explain it first, and then I'll give you some time to work on it. Okay, it says that Paul is pushing a couch up a ramp into a moving truck at constant velocity. Okay, that's a key. That tells us what? Forces are balanced. If he pushes with a force of 241 newtons directly to the right, which means not at any angle, what is the coefficient of kinetic friction? So I really want to know what that coefficient of friction is. And it says the mass of the couch is 36.3 kgs. Okay, the moving truck's ramp is at an angle of 21.5 degrees. But Paul, he's not crouching down and pushing up in the direction of the ramp. He's pushing directly into the couch. So he's pushing in a direction that is parallel to the ground. That's what makes this problem a little bit more complex. So I need more space, so I've created another slide right here, and I'm going to draw the free body diagram with you just to help you get started, okay? So we see that ramp. Let's try and draw it as big as we can here. Okay. And this is the couch. Okay, that's the couch. What was the mass of that couch? 36 point what? 36.3 kgs.
Yeah.
Okay. Now, Paul is pushing into the couch, straight, horizontal or parallel with the ground. So, what was his force that he was pushing it with?
241.
241 newtons. Okay, so 241 newtons. It goes right here. That's his applied force. Okay. All right. Now, that complicates this problem a lot. So, what was it asking us to find again? Coefficient of friction. So I want to find what mu is. And he was moving at constant velocity, right?
Yeah.
Okay. So those are some clues. Anything else that we needed to know? Not really. Okay. So what I would like to do is give you some time to try and solve this on your own. You're going to have to draw your triangle here, but you're also going to have another triangle here. So think about that. You're going to have your triangle that we've been drawing all day here, but you're going to have another triangle here, because this is force applied. Okay. And see if you can solve for the coefficient of friction between the couch and that ramp. I'll give you some time. Once you've tried it on your own, and you've got as far as you can get, maybe you get all the way to the end, then hit play and see if you got it right.
I'm weak.
Okay, let's see how far you got, and maybe you got all the way to the end, and see if we can figure this problem out. Okay, let's start by drawing force of gravity straight down. Okay, this is force of gravity. We know that the normal force on this couch is going to point perpendicular to the surface of the ramp. And we know that the normal force kind of continues down below, which creates my force of gravity in the y. And if we complete the triangle, we've got force of gravity in the x here. This is a right angle. Okay, what was the angle of this ramp, guys? 21.5 degrees. If that was the angle of the ramp, that is also the angle right there at the top of our triangle. So let's start there. Let's solve for the magnitudes of all of those forces first. Force of gravity, 36.3 times 9.8. Did you guys get 356?
Yes.
356 newtons. Okay. If I'm going to solve for this adjacent side, I'm going to use cosine, right? Cosine of 21.5 is equal to adjacent FGY divided by the hypotenuse, which was 356. Okay, so FGY is equal to 331. Did anyone get that? Okay. 331 newtons. FGX is the opposite side, so I'm going to use sine of 21.5 is equal to FGX, the opposite, over the hypotenuse was 356. I'm going to take both sides, times it by 356. So FGX, 356 times the sine of 21.5. Did you guys get 130?
Yep.
130 newtons. Okay, 130. All right. Okay. Well, if he, let's label all the other forces that we know. Is the couch moving this direction, guys?
Nope.
Nope. So we know that the normal force has got to be equal to what? 331. Maybe. We're just going to put 331 for now. That could change depending on our other triangle. Okay. So now that I've got this triangle all figured out, okay, let's draw the triangle where he's pushing. Because he pushed straight into it horizontally. He didn't crouch down and push up in this direction of the ramp. So let's see how that affects the physics of this. Okay? So if we draw this triangle in,
No.
okay,
I misplaced something.
that makes a right angle right there. We're going to call this side of the triangle force applied in the y direction. We're going to call this side of the triangle the force applied in the x direction. Because, guys, he's pushing straight into it. Is all of this 241 newtons going to be transferred into moving this couch up the ramp? No, because that's just, we got to find the component that's parallel to the ramp, which is Fg, or force applied in the x. Okay, well, if this angle is 21.5, we can solve for it using geometry, but just take my word for it. This is going to be 21.5 right there. Now let's use trigonometry to solve for force applied in the y and force applied in the x. Okay? So let's do force applied in the x first. That's the adjacent side. So I'm going to do cosine of 21.5 is equal to force applied in the x divided by the hypotenuse was 241 newtons. Okay? Times 241 by both sides, it cancels out over there. 241 times cosine 21.5. So force applied in the x direction is equal to 224. So see how not all of his force is being transferred and is moving that couch up the ramp. So really, by being lazy and just pushing directly into it, it's costing him some force, right? It's costing him.
Yeah.
Now let's figure out what force applied in the y is. So it looks like it's opposite. So I'm going to do sine of 21.5 is equal to force applied in the y divided by the hypotenuse 241. Times both sides by 241. It cancels out on the right. So 241 times the sine of 21.5 is equal to 88 newtons. So this one is 88 newtons. Okay, well that kind of complicates things because by him pushing into the couch horizontally, does the couch now, like for the ramp, does it feel like this couch has more weight than that?
Yeah.
It does. And so this has got to be added to which one?
The weight.
What other one is coming in this direction this way? FGY. So let's add those two together because that's everything down. Okay, so what's 331 plus 88? Is equal to 419. So if everything down is 419, what does that tell us about the normal force? Yeah, it's got to be 419. Do you guys see why that normal force went up?
Yeah.
Okay. All right, now let's draw in the forces that go up and down the ramp. What's making this couch go up the ramp? Really? What force was it? Force applied in which direction? Force applied in the x direction, which was 224. Notice how this one's parallel to the ramp. So this is got to be 224 newtons. Now, if you let go, which way is the couch going to go?
Down.
It's going to go downhill. So, but it's moving up at constant velocity. So if it's moving up, which way should I draw in friction? Down, because it always opposes motion. So I know it's getting kind of messy here. Let's see. Force of friction is coming down. How do we solve for force of friction? Mu times the normal force. Do I have the normal force?
Yeah.
Do I have force of friction? Do I have coefficient of friction? No. So I've got to be able to solve for force of friction somehow. Is there anything else that's making this couch move down?
Track the weight of X.
Yeah, force of gravity in the X is also going to make it move down, right?
Yeah.
So, getting really messy, but force of gravity in the X, what does that equal? 130? Okay. Is there anything else making it move down? Nope. So, it's moving at constant velocity, which means that the forces have to be balanced. If everything up is 224, everything down has to be 224. So everything up is 224. It's got to be equal to everything down, which was FGX, which was 130. And then what else was going down was force of friction, right? So what does force of friction equal to? 94 newtons. So I'm going to put that in right here, 94 newtons. Okay. Now that I have force of friction and normal force, can I solve for the coefficient?
Yeah.
Yeah, let's do that. Force of friction is equal to mu times the normal force. Force of friction was 94 newtons, equal to mu. And the normal force was what? 419. Okay. Let's divide both sides by 419. What does mu equal? 0.2. Okay. And that is the correct answer. That's a great problem, isn't it? Hey, let me say something about this. I would never ask a question like this on the test unless it was like a bonus question. This would be a great bonus question. But does everything make sense in terms of Newton's laws of motion? I hope so. Hey, before we stop the video, you now know enough. You love it when I say that. Hey, guys, just a second. You know enough to do the inclined plane worksheet in your student workbook. So please go to your student workbook and do the inclined plane worksheet. And hopefully this helped.